Hey everyone, Chang here and welcome to my channel. For today's video, I thought it'd be a good idea to break down a formula. Now, in our study of math, there's always going to be hundreds, thousands of different formula that we quote-unquote should memorize. But that's not the case. If we try to memorize it, we're wasting a lot of time, we're going to forget it, get it all mixed up, and it's just not very useful. So, there are some formulas, because the proof and the concept is so drastically long, sometimes it's just worth memorizing. Other ones, I feel like it's better to understand the concept and be able to come up with the formula yourself, so that when you forget the actual formula, it's easy to just recreate it. This one right here is a fairly simple formula, but actually gets a little confusing if you forget which one is the adding, which one is the subtracting, and why it works. This is the distance formula. So the distance formula, this is the actual distance, is equal to the square root of parentheses, you have x2 minus x1. Now remember, these are just talking about two different x coordinates, right? Squared plus y2 minus y1, which again, these two are talking about two y coordinates. Now, normally when you see something like this, they give you 2 points. They give you a point that is basically known as x1, y1. Of course, there's usually numbers in there, but then the x1, y1 just to show you that this is 1 point. And the other one is going to be x2, y2. Now, before I just break down where this comes from, notice why this works. The idea that x1, x2, y1, y2 could be positive or negative, right, in the end, doesn't really matter. Because guess what? If you have these two numbers subtract, and let's just say x2 is a smaller number, x1 is a bigger number, and this becomes negative, who cares? Because when you square it, that becomes positive. The same thing. When you square it, that becomes positive. So the square root is never going to not exist or doesn't work. They're always going to be adding two positive numbers, or worst case scenario, 0. And then this formula will still work. Now, this formula, where did it come from? Well, actually it's based on, you can say, another formula or another concept. One that's actually extremely easy for us. A squared plus b squared equals c squared. Now, hopefully you guys can recall where this comes from. If not, that's fine. It's just basically talking about right triangles, right? Always, it doesn't matter, you can interchange the a and b. A, b, and the last one, the hypotenuse, is the c, right? So it's always going to be a squared plus b squared equals c squared. And this only works for a right triangle. Now, this right here is basically this guy. How does that work? Well, the idea is that for whatever 2 points, it doesn't matter where they are located, right? And you're trying to find the distance. Let's just say the distance right here. We can always, and here's the key, we can always make it so that we are talking about basically a right triangle, right? That's the whole key of this whole thing, right? Doesn't matter how the distance is oriented. It could look like this. It could look crazy like this, right? Once again, we can always make it a right triangle. The only ones where we can't really make a right triangle are, well, vertical lines or horizontal lines. Now, if it's a vertical line or a horizontal line, basically you have the 2 points and then they're going to be the same. You just find whatever's different and then you subtract them. So for example, if it's a vertical line, guess what? The x coordinate is going to be the same no matter what. The y coordinate, you just get the top one, subtract the bottom one, and then you basically have your little distance right there, right? And the same thing with this one, right? If it's a horizontal line, then you have your y coordinate is going to be the same. You just get the x coordinate, find the difference, and there's your distance. It's the slanted one that's a little more tricky, but that's where this formula comes in. But once again, remember, key is that we can always make right triangles out of all the distance. So if that's the case, that means if we can find a squared and b squared, we know what the c squared is, or in this case, the distance, right? So same thing, a squared, b squared, we know what the distance is. That's where this comes from. So how would we know that? Well, I'm going to erase this and we're just going to recreate this whole diagram, and I'm going to talk about this formula in particular. All right, so here we go. I drew the diagram here. We have our distance formula. We have our two little points that we're going to talk about later. And we have our a squared plus b squared equals c squared in talking about right triangle. So our distance, this is what we want to find. We have 2 points here. Now 2 points, usually they're given a coordinate. So let's just name this, let's just call this point 2. Just because it's higher, I like it. Point 2. And then, of course, with point 2, there's going to be x2 and a y2. And then this is going to be point 1. And this is going to be x1, y1. Okay, cool. All right. Well, remember, with any distance, or I guess you could say between 2 points, you can always create, I'll just make it solid so it's easier to see, a right triangle. Cool. So with the right triangle, that's simple. We can actually use this to find D, because this would technically be our A, this would technically be our B, and D would technically be our C. So if we can find this, we can find D. So let's look at this really quickly. All right, well, this is a horizontal line. So if it's a horizontal line, the y coordinate is the same. In order to find this length, it's just difference of x. So it's going to be x2, which is usually right here, right? Minus x1. So it's going to be x2 minus x1. That's the length of this guy right here. Well, by that same logic, here we are. This is a vertical line. The x coordinate is going to be the same, so it's only the y coordinate that we're worried about. It's going to be y2 minus y1. Okay, that will give us this length right here. Now, according to this formula, we have our a squared and our b squared equals our c squared, right? So it's going to be x2 minus x1 squared plus y2 minus y1 squared equals d squared. Cool. Plain and simple. But we don't really want d squared, we want d. So what we're going to do is we're going to square root both sides. When you square root both sides, the square root and the square cancel. So what you have now is just d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, this turned out really nicely because I named this one point 2 and I named this one point 1. If I switched it over and I said this is point 1 and this is point 2, does it matter? No, not really. Because remember, in the square root, there's that square. The square, it doesn't matter if the difference end up being positive or negative. Because when you square it, guess what? The answer is still going to be the same. Let's just imagine, I'm going to make up a number that after you subtract it, let's just say it's 2 or negative 2 if you flip it over. What does it matter? Guess what? 2 squared is 4. Negative 2 squared, still 4. And that's the same for all numbers, right? 2 negatives multiplied together is going to be positive. 2 positive multiplied together is going to be positive. So in this case, if you're squaring it, all the negatives are going to disappear and they're going to be positive. So that's why this formula works. So even though it looks very complicated and it's hard to memorize sometimes, because when I was trying to memorize it, I always get the subtraction and then adding mixed up. And of course, if you get it mixed up, you know, the distance formula doesn't really work. But it's only after I found out that this distance formula is really just nothing more than a squared plus b squared equals c squared. Written in this format, it makes a whole lot of sense. Let's start practicing with this formula itself and then just see what we can do with it. All right, so let's look at this one. We have 2 points right here, right? Let's just call this one point 1 and this one point 2. So using the distance formula is actually fairly simple. D equals square root x2, let's just look at the point 2, right? x2, the x coordinate is going to be 1. Subtract the point 1, because we want x1, right? The x coordinate is going to be minus 1. So minus minus is plus 1 squared. Okay, plus sign afterwards. y2, which is right here 2, minus y1, which is right here, is going to be 5 squared. Okay, what does that give us? Well, quite simple. 2 squared plus, and this is going to be negative 3 squared. Right? All right, cool. So that means it's going to be square root of 4 plus 9, or just the square root of 13. Now, what would happen if we switched it? Instead of this is going to be 0.2 and 0.1 right here. the result should be the same. D equals the square root of x2, in this case, it's going to be, right here, it's going to be negative 1 minus x1, if we think this is 0.1 now, minus 1 squared. Plus, and what is it? Y2, it's going to be 5 minus y1, it's going to be 2 squared. Notice that it doesn't really matter because guess what? That's just going to be the square root of negative 2 squared plus 3 squared, which if we simplify it, 4 plus 9, which is the square root of 13 still. So hopefully this at least demonstrates that it doesn't matter which one you choose as 0.1 or 0.2. The square inside the square root cancels out the whole negative variations of it. The end result is still going to be the same. Alright, so let's just do these two problems very, very quickly. Now, I erased the distance formula. Oh no, what do we do? Doesn't matter, right? Because once again, we know what the distance formula comes from. All we need to know is the 2 points and what we're looking for. Well, I'm just going to label this conveniently. This is all going to be 0.1. This is all going to be 0.2. Two different numbers, of course, or two different problems. Now, here's the thing. Remember what we're doing. Once again, we want to find the length of the x, right, which is the horizontal, and the length of the y coordinates, which is the vertical, and then it creates a right triangle. And with that right triangle, we know that a squared plus b squared equals c squared. And in this case, our c squared is our distance, right? So let's look at this. All right, well, we don't know the formula, but we know that we need to find the distance of the x and the distance of the y. Well, 6 is going to be our x2 minus 5, right? Our x1. In this case, that gives us our length of x plus, now we have to think of our length of y. Once again, same thing, 3 minus 7, right? Our y2, y1 squared. Once again, not c squared, or d squared in this case, we want d. So we have to take the square root of it all. Well, that's pretty simple. What is that? That's going to be the square root of 6 minus 5 is 1, 1 squared, plus 3 minus 7 is negative 4. That's going to be negative 4 squared. Okay? So, if that's the case, let's just make it so that I have a little more room here. It's going to be the square root of 1 plus 16, which is going to be the square root of 17. And just like that, right? Flip the order, trying to see if you can get square root of 17, and it will probably still work, hopefully. Now, let's look at the second one. Very quickly, once again, distance 7 minus a minus plus 2 squared, okay, plus, and it's going to be, what is that? Negative 9 minus 5 squared, square root, okay? Well, that's 9 squared plus 14 squared. Oh dear, I don't think my mental arithmetic might handle this. What is that? 81 plus 196, I believe, right? Check my math. All right, so 196. In that case, it's going to be what? 77277. So the square root of 277. And of course, if, you know, my math is correct here, and it's the square root of 277, if we flip it, and this one's 0.1, 0.2, the answer should still be the same. All right, so now that we've reached the end of this video, hopefully this distance formula is actually a lot easier than we first anticipated. Yes, I'm not saying that the formula itself is super difficult and that memorizing it is insanely, I guess you could say, complicated. No, if you memorize it, great. But guess what? Every time you memorize a formula, there's always room for mixing up little symbols or mixing up the orders that can just drastically destroy your chance of getting it right. As long as you understand where the formula comes from, if it's not too complicated, too hard to just follow the train of thought, it's always a better idea to just go with that. The idea with distance formula, once again, is very simple. There's the adding and subtracting, the square root and squared, and oh my god, all that, but it's just technically a squared plus b squared equals c squared. The idea that no matter what the distance is between 2 points, once you draw it, that's technically the hypotenuse, and we can always create a right triangle. And with the concept of a right triangle, immediately we came up with a more complicated looking formula that uses such a simple thing. Now, of course, if there is a single formula that you need to memorize that I feel like is extremely useful, a squared plus b squared equals c squared is one of the top ones, right? You're going to see it in distance formula. You're going to see it in, I guess you could say, the special triangles. You're going to see it in unit circles, all that stuff. So, I guess memorize that one. Thank you for watching this video. See you in the next one.